Well, I'm not able to be with you today, but I wanted you to be able to continue working with quadratics without a delay. So we're going to continue the work that you started a couple days ago. 2 days ago you started graphing quadratics and you looked at 4 different things that were happening to the quadratics, and we'll talk more about those on Monday when I'm back. But hopefully you were able to notice that the graphs were moving around, and today we're going to talk about just identifying the different parts of the quadratic graph, and then Monday we'll put all of that together. So let's go ahead and get started. So as I said, we're looking at the parts of a quadratic graph. So we're going to identify several different parts, and if you would draw these in on your guided notes on the graph that I provided, and then also write the definition of the term next to that. So the first thing, or next to each word. So the first thing we're going to talk about is the vertex of a quadratic. The vertex is either the maximum or the minimum point of the graph. So that means it's that bottom point where the graph changes direction. So it gets down to that point and it turns and goes the other way. And so I've identified that with the arrow pointing at that exact point where it's going to turn and go the opposite direction. And so in this case, that vertex is sitting at 2, -3, at the point 2, -3. The next thing that we're going to identify is what is a maximum or minimum. Well, it's either the highest, which is the maximum, or the lowest, which is the minimum point on the graph. So this graph, the vertex, is sitting at the lowest point of the graph. There are no y values on this graph that go below -3. So this would be considered a minimum point. So the vertex is a minimum for this graph. If the graph were flipped upside down, and it were opening upside down, then it would be a maximum point for the graph. It's the highest point that y would be. If I draw a line right through the middle of that parabola going vertical, that would create the axis of symmetry, and that line just divides the parabola into 2 congruent parts. If I were to fold that parabola right on that dotted line, then both sides would match up with each other. It would be like a mirror image. So that would be the axis of symmetry. It divides that parabola in half vertically. And notice that that axis of symmetry runs right through the vertex. And so if we were to talk about that line, that axis of symmetry line, that's a vertical line, which means it has no slope, an undefined slope. Because remember, the guy would fall off and plunge to his death if you were trying to walk on that. So the equation for that line would be x equals 2. So the equation of the axis of symmetry line would be x equals 2. The next thing we're going to identify are the x-intercepts. That's where that parabola crosses the x-axis. So you can see on this particular parabola, it doesn't cross at a nice neat number. You could probably estimate those values pretty closely. Looks like maybe it's crossing at 1/4 0 and maybe 3/4 or 3 3/4 0. And so that's the x-intercepts, wherever it crosses the x-axis. So there's only going to be 2, because that won't pass through 3 times. It could be 1, because the vertex could be sitting right on the x-axis. Or it could be sitting above the x-axis and never cross it. So there could be 0. So it could be 2 x-intercepts, 1 x-intercept, or 0 x-intercepts. And we'll talk about those more in detail the farther we get through this unit. The next thing we're going to identify is the y-intercept. Where does it cross the y-axis? And so this parabola happens to cross the y-axis at the point 0, 1. And I've drawn an arrow to indicate that. So pretty easy. You just read it right off the graph. The second to last thing we're going to look at is the domain. So remember, these are functions. They all pass the the vertical line test. There's only, if I draw any amount of vertical lines in there, it will only cross the graph one time. And so the domain for this would be all the x values on the parabola. Well, if that parabola extends forever in both directions, it's just going to keep going up at a slope. And so x is going to just keep getting bigger and bigger and bigger, or it's going to get smaller and smaller and smaller in the negative direction. So the domain for this would be all real numbers. So if we wanted to write it in interval notation, it would be negative infinity to infinity. The range, however, does not include all of the y values, because there's a minimum point on this graph. The lowest y value of this graph is -3. So the graph will never touch anything below -3 on the y-axis. So if we look at or not on the y-axis, but in the y direction. So if we look at this, this would be, it's going to go off forever, going up, and so the y values are going to get bigger and bigger and bigger, so it's going to go toward infinity in the positive direction, but the lowest value is going to be -3. So if we were writing this in interval notation, it would be -3 to infinity, and that would be our range. So typically with the quadratic functions, the parabolas, we're going to have a range that has some either low value or high value, and then it's either going to go in the positive infinity direction or the negative infinity direction. And the domain is going to be all real numbers, because it's always going to go off in the x direction both ways infinitely. So here's just kind of a recap of what we've identified on the graph. So if you didn't draw along while we were going through the video, then you can do it now. You can just pause the video and fill that in. This is a little bit different parabola. It crosses at some different places. So the vertex appears to be 1, -4. The x-intercepts appear to be -1, 0, and 3, 0. And the y-intercept appears to be 0, -3. And the axis of symmetry appears to be x equals 1. And the range, or I'm sorry, the domain would be all real numbers, and the range would be -4 to positive infinity. So I've left you a worksheet to practice identifying these parts. It's not super long, but there's a lot of parts to identify for each graph. So do a good job on that, turn it in when you're done, and we will bring all of this stuff together on Monday and continue our work with quadratics. Have a great weekend. See you Monday.